Okay, you guys, I want you to go to the vocabulary for chapter 1. So you're going to open this up. And then just like yesterday, I'm going to take you through this. And then I'm going to switch to a different screen, but you're going to stay where you're at here. Okay. Chapter 1 stuff we've already done. Let's come down here to chapter 2. Okay, well, chapter 2, I think it said 4 definitions. Yep. Wait, maybe it's just 3. 1, 2, 3 definitions. All right, this one will be a little shorter. Once again, today the notes are on the Google Classroom for you, so you don't have to write all this stuff. But anytime you need to refer back to this stuff, it'll be on Google Classroom for you. Okay, let's start off with a segment. Now, if you think back to yesterday, we had a line. What do we put on the end of a line to show that it keeps going forever and ever? Arrows. Arrows, okay. Those arrows means it keeps going, it extends forever and ever, it never stops. A segment does stop. It's going to look just like a line, except on the ends, we're going to have endpoints where it stops. So here's a picture of what it looks like. This is a segment. You got points A and B on the end. It stops at points A and B. Okay. So the definition of it is part of a line consisting of 2 endpoints and all the points in between. And when we name a segment, we name it by using the 2 endpoints. So this one over here, this one you could call segment AB, or you could call it segment BA. Once again, the order of the letters is not important. You just got to make sure you name it by the order, by the last 2 points, at the points on the end of the segment. Sometimes you're going to have more than 2 points on your segment. When that happens, you end up sometimes forming 3 different segments on this one. So we've got the big segment here with A and D as the endpoints. That's segment AD. But you've also got 2 little segments inside there. Segment AB, this little one here, and segment BD, this one right here. So if they put a 3rd point on your segment, it's going to split it up so that you actually end up having 3 different segments. So when it comes to a segment, remember segments have endpoints. They're going to stop at those 2 endpoints and use those 2 endpoints to name the segment. Any questions with the segment? Okay, if they ask you for the measure of a segment, the measure of a segment is the length, how long the segment is. Okay, so over here in this picture, this segment AB, they put a little 4 on top of it. That means the length of that segment is 4. If they put 2 capital letters next to each other, that means that's how they want you to find, or that's how they designate that they want you to find the length of the segment. So the capital letters A and B next to each other means they want you to find the length of segment AB. In this case, that length would be 4. Okay, and that's something you're going to want to remember, because when you get to your test, there will be times when they just put the 2 capital letters next to each other. They may say find AB. You need to know that that means they want you to find the length of the segment. You come over here and look at it, the length would be 4. All right, any questions with the measure of a segment? And we've got our last one today. Congruent segments. We're going to do a lot with congruent segments this year. Congruent segments, first of all, definition, they're segments that have the same length. So if you got 2 segments that are both the same exact length, that's going to make them congruent to each other. In our picture right here, you've got segment AB and segment CD. They both have a length of 4. That means they're congruent to each other. So the symbol we're going to use for congruent is this little symbol right here, right between the AB and the CD. It's an equal sign with a little squiggly line above it. When you see that, it means congruent. This little statement right here is read as segment AB is congruent to segment CD. So that means they're congruent. If you have an equal sign between them, that means they have the same, their measures are the same. So really not just real technical difference there, but that's congruent, that's equal. It means they have that same length. Okay. Now, here is a big one. You're going to see a lot of this as we go through the year. When they want to show that 2 segments are congruent to each other, they can either show that they're the exact same length by giving them a number. In this case, they were both a length of 4. Or what you will more often see than anything is they will put a little, what I call a little tally mark through the segments. If two segments have that same number of little dashes, little tally marks through them, that means they're congruent to each other. You're going to see a bunch of that as you go through this year. So when you see that little mark, and usually they're going to put that mark in red. So this part right here. Usually put this mark in red, this mark in red. Those two have the same number of marks. That means they're congruent to each other. All right, I think that's it. Any questions with congruent? Okay, this is going to be a short day. Now, you guys keep your screen where it's at. I'm going to switch to a different screen. Finish off notes we did yesterday. Now, once again, you don't have to write the notes today. This will be on Google Classroom for you anytime you need it. And let's scoot through the ones we've already done until we get to the segments. Oh. Something's not working here. All right, here's our segments. So on this one, they want us to name the segments in the picture. Now, remember what I said earlier. If they put a third point on your segment, that's going to make and end up making 3 different segments. So we have 3 different segments up here in this picture. Let's see if we can name them. Anybody give us one of them? Start learning your names, Jackson.
BC.
BC would work. That's this segment right here from B to C. There's one. Dean, what's another?
AC.
AC would work. That's the whole thing from point A all the way to point C. There's one other. Yep. You're Landon, right? Landon said AB. Segment AB goes from point A to point B. Now, when I put those letters next to each other to show it's a segment, the symbol, I don't know if I remember telling you this part, the symbol for segment is the little dash above the 2 letters without the arrows. Did I tell you that? I didn't. So that little dash without the arrows means that's a segment. This is segment AB, this is segment BC, that one's segment AC. All right, let's try the next one. Now they're going to have to start doing something with the lengths of the segments. So here they're going to tell us that segment AB is 4. If I come down to my picture, this segment right here is 4. And whoops. Segment BC is going to be 6. That's this segment right here. BC is going to be 6. They want us to find the length of AC, the entire thing. Now let's see if you can kind of work yourself ahead a little bit here. If AB is 4 and BC is 6, can anybody tell me what the length of the whole thing would be? It's going to be 10. How'd you get 10? It's up there. Because I went ahead one. There we go. It's going to be 10. Here's why it's going to be 10. If we add the 2 little segments together, AB and BC, these 2 little segments, it will give us the entire segment AC. So when you add 4 plus 6 together, 10. Okay. That's called the segment addition postulate. We're going to talk more about that in chapter 2. But this is just kind of a little preview for you here. That's called the segment addition postulate. All right, now, same type of thing, but we're going to make you think about this a little bit differently. This time, they're going to tell us that AC is 15. That's the entire segment. The whole thing is 15. And AB, this little part right here, from point A to point B, that's 7. Now they want us to find BC. Anybody figure out what you do to find BC? Rating?
Minus 15 by 7.
15 minus 7. The whole thing is 15. The little part here, AB is 7. You take 15 minus 7. That's 8. Or another way of looking at that, you add the 2 little ones together, you get AC. AB, that's 7. AB was 7. BC is the one we're looking for. AC was 15. If you solve that equation, you would subtract 7 from both sides. 15 minus 7 is 8. Any questions with that? Okay, now the last thing we're going to do is throw some algebra in here. Now this time, DE is 4x plus 3. That's this segment right here. EF is 2x minus 7. That's this little segment here. And DF, the entire length, is 32. They want us to find DE and EF. They want two things. They want the length of DE, this part here, and the length of EF, that part there. And we got a little hint here. We have to find X to do it. Now, this may be a little bit of a stretch, but we're going to see. Can anybody give me an equation that you could use to solve for X? Dean, what do you think?
6x minus 4 equals 32.
Okay, that is correct. Here's where that came from. These two little segments right here are these two little segments in our picture. If you add the two little segments together, you get the entire thing, which is 32. So he took 4x plus 3 plus 2x minus 7, those two little segments, added them together, and had to equal 32. So we'll go to the next screen to show you that. Got to write an equation. Okay, so if we add the two little segments together, DE and EF, that'll give us the length of the long one, which is DF. Then we just replace it. DE is 4x plus 3. EF was 2x minus 7. And DF, the length of the whole thing, is 32. Now you just do the algebra. 4x plus 2x is 6x. 3 minus 7 is negative 4. Get 32 on the right. We can solve it. If you add 4 to both sides, you get 36 here. Finish it off by dividing by 6, and X is going to equal 6. Okay, so we found X. Now, if you remember the original question, did they ask us to find X? No, they asked us to find DE and EF. That means they want to know the length of DE and the length of EF. So we found X. We're not quite finished yet. What we're going to have to do is finish this off by putting X into our equations. So on DE, DE was equal to 4x plus 3. We just found X to be 6. So if you put 6 in there for X, 4 times 6 is 24, plus the 3 is 27. That's going to be your longer segment here, DE. The shorter segment, EF, our original problem, it was 2x minus 7. We just found X to be 6, so we put 6 in there for it. 2 times 6 is 12. 12 minus 7 gives you 5. There's the two lengths that we want, 27 and 5. Okay, and then we said, if you remember the original problem, we said the whole length DF was what? 32. If you add 27 and 5 together, this one's 27. This one over here is 5. If you add 27 and 5 together, then you get 32. That's 27 plus 5 is 32, so we know we did it right. That's all we got for you. That is it. Any questions? All righty. Then today, we're going to start your homework together. And then we'll let you finish it off on your own.
Are we gonna need our computers?
I would keep your computer out just so you can refer back to it if you need to.